Hi, and welcome to Chapter 4. In this section, we're going to be talking about the basics of right triangle trigonometry, which you might have seen in uh, your previous classes somewhere. You might not have gone into as much detail, but we're going to go ahead and look at ratios that are present whenever you have a right triangle. And it's important that you remember that these apply only uh, for triangles with a right angle, because the main side we're going to be defining is the hypotenuse, which is the longest side of a right triangle, and it's going to be located directly across from the right angle. It's the only side that the right angle is not touching. Now we have two legs that have specific names, but it depends on which angle you were referring to. So if I have this angle up here, and usually we refer to angles as the Greek letter theta. If I'm referring to this angle up here, the side that's opposite, or I'm sorry, the leg that's opposite, is going to be over here because that angle is not touching this one, this side. And the leg that is adjacent would be here because that's the angle, or that's the side this angle touches that's not the hypotenuse. Now, these sides could be opposite of each other. If I was calling this angle over here theta, then that would make this side opposite of that angle, and this side would be adjacent to that angle. So those are my hypotenuse and my two legs defined based on which angle we call theta. Now with my trig functions, they each hold a ratio based on the angle you choose as theta. Sine theta is the ratio of the opposite side over the hypotenuse. Cosine of theta is the ratio of the length of the adjacent side over the hypotenuse. And tangent of theta is the ratio of the opposite side over the adjacent side. So those are my three primary trig functions, and they each have reciprocals as well, which we'll get to in a second. But real quickly, I want to introduce you to a mnemonic device you can use to remember this. It's referred to as Sohcahtoa, spelled like this, Sohcahtoa, because so represents that sine is opposite over hypotenuse. This represents that cosine is adjacent over hypotenuse. And this represents that tangent is opposite over adjacent. So then we have the three reciprocals of these functions. Cosecant of theta is the reciprocal of sine of theta, which would be hypotenuse over opposite. I'm just flipping around the fraction there. Secant is the reciprocal of cosine. So we have hypotenuse over adjacent. And then cotangent is the reciprocal of tangent. So we have adjacent over opposite. So let's now apply that to how we would find the exact values of those trig functions. So if we label our hypotenuse, or I'll keep consistent and label the hypotenuse red. So with this angle theta, the opposite leg to theta would be this 33, and the adjacent leg to theta would be this 56, which touches it. So when I put in my trig functions, sine of theta would be my opposite, remember Sohcahtoa, over hypotenuse. That's the so. And that's going to be 33 over 65. And I don't believe that that reduces. So then we have cosine of theta is adjacent over hypotenuse. And that's going to be 56 over 65. And I don't think that reduces. Finally, we have tangent of theta, which is opposite over adjacent. And that one would be 33 over 56. None of those reduce, so those are my three answers for sine, cosine, and tangent. Now, to get the other three, remember, we just take the reciprocal. So cosecant of theta would be 65/33. Secant of theta would be 65/56. And cotangent of theta would be 56/33. And that's how you find all 6 of the trig functions. So now go ahead and see if you can figure out what the 6 ratios would be for the trig functions for this triangle.